Now we're translating from English into logical expressions. For this, there actually could be there could be a couple of solutions, but only because of negation, if negation even comes up. So just a heads up on that. But on your way to complete this is basically, number one, you want to rewrite the statement to make sure that everything is implied, the quantifier and the domains is explicit. Because if you look at the example, especially the first one, it's not. So you have to make some assumptions here. I really wouldn't say assumptions, but you want to clarify some things, put it that way. Then your second step is to include the variables x and y, and again, specify the domain. So in our first example, which is not so hard, the second one is much more interesting. So in our first example, we're going to translate the sum of two positive integers is always a positive into a logical expression. So how are we going to do that? First, number one, we're going to go ahead and start putting in some more explicit items in here and start turning into some equations here. For all positive integers x and y, then x plus y is positive, so x plus y is greater than 0. Nothing crazy about that, okay? Second part, so the result is now again, we start first part is we put in our quantifiers. We're looking for any x, we're looking for any y, as long as x is greater than 0 and y is greater than or equal to 0. Therefore, when we put those two together, it's going to be greater than 0. And the domain of x and y is our positive integers. Now, we could also do the same thing, a little bit shorter, okay? Notice all values of x and all values of y, x plus y is greater than 0, where the domain, and notice really the only thing that's different is really we're saying all positive integers. That's the only thing that's different. We changed our domain a little bit, but either one of these will be just fine. Now I'm going to start breaking it into functions for number 2. So first I'm going to have p with the w meaning the woman, and then the f. And that's going to be translated that the w has taken f. So the woman who has taken a flight, that's going to be that part. And then the q is going to be f of a, which means it's going to be f is a flight on a, which is an airline. So let me break down the answer. Let me go from the inside first. So this last portion right here means that a woman has taken flight. That's the P part. And that flight was on some airline. Now, that doesn't answer everything, but the interesting part is that we need to start, just that alone is not enough. So we have to quantify, or we have to there are variables from that. So first, we have a woman that's going to fly on all airlines and ends up existing on a flight that ends up going on all of the different flights from all over the world. So that's where we have our first part is just trying to get that we're flying and has flown different airlines, and then we can quantify it with what has been done in that to match our who has taken the flight, and on every airline in the world there's your A, and so for every flight, and there's our universal for that. So here's our first big problem with this. They get harder as it goes down, but if you can get the first couple and the last one's a little bit more tricky, I get that. So work on this for now, draw it out. Notice there isn't too many ands and ors and all that stuff that you saw in that previous example. Number 2 has a couple, but nothing crazy. So try to use those as examples, start answering those, and we'll get to an answer here in a moment. Take your time. This is gonna be a while. And please, again, make sure you hit pause. If you screw up, so what? Just hit pause and then we can go over and answer here in a little bit. But try it out first, please. So on the first one was actually I'm going to say relatively easy. And that's because of the words that it's giving out here. Which one or more of the following statements above says that anyone, so that means or generalized quantifier, has an address. Notice it's a single address. There's your other quantifier. So our general is going to take care of our anyone, and our existential is going to take care of our single address. Which one of them has that combination is actually going to be B. So that was their kind of dig giveaway just from the overall statements. Now, I still spell out, though, what each of them say. So I would sit there for a moment, read what it's got. We have, there exists someone who lives at every address. Notice how the overall quantifiers and nested quantifiers are set up. It should match, you'll see the variables being highlighted here, should match up with what we've got. So notice there's some dead giveaways on exactly how it's set up by the order and what the actual variables are in this case for X and Y. This one's also very similar. That last, the which one or more of the following statement says that there's a movie, a single movie, that everyone in our class hates. That's funny. So again, out of all of these, A is going to be the one. Now, if you picked between A and B, I get you. So, but A is really the answer for this one. So A is correct because it's read as there exists something X such that X is a movie, and for all Y, if Y is in our class, they hate X. So again, I'm trying to put out, there's a movie, a single movie, so that's our existential, that everyone in the class, so that's an existential followed by a universal quantifier. And which one has that? Well, it's these two here. You probably didn't notice the X here, and that's why some of you might have selected that. But it is different values, so that's why it's A for that one. So, but notice again, I go over all of the different sayings. So if you picked one, read over it and go from there. But A is the correct answer on that one. And finally, number 3. It's the same idea again. Read what it says, that every pen, so it needs to have the universal quantifier in front of it for pen, which is, well, X. And then we have a single color, so it's an existential for color. Which one has that combination? And frankly, the only one it does is really this A. So A pushes that perfectly. And again, think of it. If it's a pen, then it has to have a single color. And that's or implies that it has a single color. So that matches that pretty well. Again, I break down what the other ones mean, so please take a look at that and see where you might have gotten off on. That's no big deal. Good from there.